Everybody, it's Tyler here at Riverbots, checking in with VEXU team KUDOS. Holy cow, this is an incredible robot they have put together for VEXU. It is a buddy climb, high-stake robot. It is one of the coolest things that I have seen. Hopefully you had a chance to see a little bit more about this. We'll be breaking down a lot of their strategy going into this, the course, and a lot of different subsystems that they've made for this robot. It's really cool. A lot of things that I think anybody can learn from and be inspired from as well, too. So let's learn more about KUDOS coming up here on Pits and Parts. Connor, let's talk about some of the build strategy behind this rowing. This is incredible and honestly ambitious task that your team has gone over. So talk to me more about really what made you want to choose this way and how it all came together.
Yeah, thanks, Tyler. So I'm the strategy lead on the team as well as the B section lead programmer. What we did is we took strategy first, right? Strategy dictated our design. So what we did is we looked at ways that we could win the match without caring what our opponents did. For our VEXU, the biggest way we can do that is looking at buddy climb. So we looked at the most feasible way to get buddy climb done, and the way we decided that was through this mini bot strategy. So we lift up our mini bot. This is our mini bot Simba, and it raises up all the way to tier 3, scoring us 24 points with this robot alone. When we score with the high stake on this robot and get this robot climbed, it's a total of 36 points from one single ring and our climb. So we really just focused on ways to win without caring what our opponents did and without scoring a ton of rings.
So talk to me about how this all kind of came together. This idea comes up. How do you actually go from that idea to saying, yes, this is actually feasible for us to do?
Yeah, so it's a bunch of prototyping, really. We did some initial tests. One of the most important things was testing our ring platform. We have to get off the ground somehow, so we intake our rings, and we had to test that over and over. Really, this was just a progression of crazy ideas that got crazier and crazier as we came up with more stuff. Originally, it was just lifting a small robot, then it was pushing off rings to climb, then it was scoring the high stake. So that's where we came up with the progression for this strategy.
Last thing I just want to ask you, what actually constitutes this robot as a robot? Because there's no wheels on it or anything like that, right? So is that a stretch, or is it like, hey, this falls in with the game parameters?
It's very clear. It's very clearly stated in the game manual that we can have stationary robots as long as they have a fully legal electronic system, which is a brain, battery, and motors. It's completely legal, and they explicitly state that stationary robots are okay.
And we'll be going more into this transformer in a little bit as well, too. So, Cameron, talk to me about the Mogo Mech, what you're using for that, and how everything came together for it.
So, due to space requirements, we couldn't exactly fit a standard Mogo Mech on a robot, so we opted to have a system that clamps down on a goal, and makes it very difficult to pull back out. This allows us to keep control of the goal while it's in the positive corner.
I want to translate this a little bit for V5RC teams as well, too, is that most teams that we talked to have had a very small Mogo clamp on that, too. Is this, having this wide clamp, is that something you think that might be beneficial for V5RC teams also?
I mean, it could be. I mean, it can grab mobile goals at a very wide angle, but at the same time, it isn't quite as well for very precise positioning.
Well, that's a fair point on that. I mean, touch it on, it's a big thing, right, with a lot of this. But I like your comeback on that. Positioning wise, it might not quite be what they're looking for. Katie, let's go over to talk about the platform, how all that comes together on there. These side rollers and this level 1 climb. I want to hear just more about how this climb really starts out.
Yeah. So for our climb, we want to get off ground 0 because then we can break planes 1 and 2 to get us up to that tier 3 climb. So what we do is we go and intake 2 rings. We start off with 1, it goes towards the back here, and then we take another one and it intakes into the front. And then we have these pancake cylinders here that push down this 3D printed platform that will push us off. And so our wheels are no longer touching the ground. And so we can spin our wheels and we're staying stationary. And then this is the base of getting that climb started. So then we'll start to expand to our level 2-tier climb.
I love the whole packaging thought of let's actually use the rings as part of what we need to get that climb going. That's really cool. When you were designing from that perspective, were there any challenges of working with the game piece to try to get that all integrated with your robot?
Yeah, so we spent a lot of time prototyping and 3D printing different types of platforms that will work best and give us the most surface area to push off of, that will also keep us the most stable. We came up with this design after many iterations and testing of we would put intake rings and then push off and then kind of like shape the robot, see if it stays stable or not. Because, I mean, once this is all the way expanded up, it's going to be a lot of weight that's top heavy. So having a good stable base is what we needed.
Speaking about integration, Nathan, by the way, this docking mech of bringing these two robots together, like sincerely, like it's like 1980s Transformers going on all together here. So talk to me more about how that comes together and a little bit more of just how you're actually able to get up to the high stake, that sort of thing.
Yeah, so this carriage in front is known as the docking carriage. It holds 2 pancake cylinders that we attach to the back of the 15-inch robot. So if you could, on the bottom of this, if you hold it like that, it pretty much clamps into these 2 pieces, these 2 holes. These button heads on the 24-inch shoots into those holes. And then we have a positive cutout right here that'll go into a negative cutout that we have under here as well. So pretty much at the very beginning of the match, the 2 robots will dock together, and then for the whole entire match, they will stay locked together.
So based on the rules then, right, like you have to have them a little bit apart from each other sort of thing, but then you can just bring them together right away?
Yes, that is correct. So the 24-inch robot, that will be 1 inch behind the 15-inch robot. And then at the very beginning of autonomous, it will drive forward, and then we'll activate our docking mechanism. And they will pretty much dock together, as we can see right here.
I mean, that sincerely is pretty badass, guys. Yeah. Like, that's really cool. But we talked earlier in regards to strategy and stuff of doing like a tier 3 climb, like, but from a docking perspective and like bringing these 2 robots together, like how did that conversation go?
So we pretty much, our original strategy was pretty much mini buddy. We wanted our 15-inch to actually be the shape of 2 rings originally, and then the 24-inch was gonna have a claw to pick it up. But then we figured we don't want the 2 robots to separate during a match because that risks not getting the climb at the end of the match. So we decided we're gonna keep the 2 robots together the whole time, and we might as well just put the claw on the actual 15-inch itself. Just make the 15-inch the manipulator and the 24-inch the rest of the whole robot.
I mean, the creativity in this is just awesome, guys. So Adrian, let's talk about autonomous-wise and how you're going about that, specifically like for skills as well too. Walk me through that.
Yeah, so since the 15-inch can only pick up 2 rings at a time, we really wanted to go for climb since that's 27 points, and we wanted to utilize our Mogo mech. So we have 4 Mogos that go in the corners because that's 20 points, and then we climb for 27, so right now we're at 47 points. And then we hopefully will get to the point where we can have our 59.1 and our 65.1, and then for our next competition, we're hoping to get 71 points, but that is definitely like a reach for us right now.
Very cool. And from looking at from a programming perspective, any big challenges that you guys face in regards to like taking this beast of a robot and trying to get as many points as possible?
It was really just positioning it and trying to figure out like how fast we have to make it go, and like just positioning it for the climb as well.
So AJ, let's talk about driver strat on here and what you're doing during a match. Especially when we talked earlier that, obviously you're climbing and getting that as well too, but what about during the rest of the match? I mean, are you playing defense? Are you grabbing rings? What's going on with that?
During the rest of the match, a lot of it we try to stay as flexible as possible depending on what our opponent does. Sometimes they get really aggressive with us, trying to stop us going back for a climb. But during the match, a lot of time is we'll take like two Mogos, because each robot can actually hold 1. So we grab 1 with the claw, 1 with the Moga, and we go sit in a positive corner, denying them not only a positive corner, but 2 Mogos, allowing them to score on, which limits the amount of rings they can score and different points that they can get with it. And then towards the end, we then go drive up next to it. As you may have noticed along the side that there's the zip ties. It's kind of like a skirt, allowing us to not only just climb from the front, but climb on any side as well, making it so it's a lot harder to defend us and a lot harder for them to stop us from getting our climb in the end.
So I want to wrap up here. Let's pass it back over to Katie. And one of the things I want to ask you, Katie, is just, how does VEXU actually work at Kettering University? We heard a couple people say, I'm part of this group or this unit and stuff like that. How does Kettering University approach VEXU?
So Kettering University, if you don't know already, has a very unique co-op program. So we do 3 months of school that's done in 11 weeks, and then we do 3 months of co-op in industries. And so we have both A section and B section. So while one's at school, one's at work, and then they swap back and forth and vice versa. So for us, as there has been Kettering VEXU teams in the past, and they tried to do one A section, one B section team. But for us, we came in and we were like, we want to combine both sections. So we both have A and B section working together. So we like to say 2 sections, 1 team. And I think it gives us a lot of connections of people in the other section that we may not see all the time. And they maybe work differently than we in B section do, or vice versa. And the way we communicate the best is like we do weekly meetings through Discord, and then we document everything. We have very good communication throughout our team and everything else. So I think that's what makes us unique, is that we can pass off what we're doing with the robot and know confidently that our teammates on the other section is going to do what they need to do. So we have a lot of teamwork, a lot of communication, which we work year round, so it's better than 3 months here and 3 months there.
Yeah, and definitely some real world skills with that too, right? When you look at
Yes.
industry, you have to have that sort of communication between teams
Yeah.
and how things work. So that's really cool.
Yeah.
KUDOS, thank you so much. This is incredible, by the way. So congratulations on building an amazing machine. Like I said, I think there's so much that teams can learn from this. So of course, you can't wait to see how you do here at Riverbots as well in the field. We'll see you later on Purdue University at their event as well too. And good luck throughout the rest of the season. Thanks a lot.
Thank you.